All right, so just to review, when you do this, your vertical asymptotes and your denominator. Don't keep it at 1/2. Resolve that into get rid of your fraction. Set it equal to 0, multiply by the denominator. Your point of discontinuity is given so that you have an x and a y point in there as well as reducing this. If you were to graph this whole thing, and then you canceled out your point of discontinuity, and try this. Graph this in y2. They are the same exact graph. It is the same graph, but the point that's missing is this point. It'll be missing from this equation because you didn't account for it at all. So because it's just a point of discontinuity and it's a removable point, you're not going to see it, any difference between this graph and this graph, because your calculator also can't jump over it.
Is it okay if I just kept the 2 factored out with that?
Yeah, you can.
So then it was
That's
2.
fine.
Okay.
Giving us all factors. No, you left the half in your thing? No.
Because you
don't
can have
yeah.
fractions.
Yeah, we don't have the fractions there. But I thought you meant like sometimes we get like 2x minus 4 if you want to take the 2x. Normally we factor everything out, but I said to the kids on Thursday or Friday, you can actually leave them like that if you wanted to, and with or without the factor. It's kind of nice to have them all factored out, but then you lose track of where did this come from. So, okay. So everybody's okay with that. So number 2, this was one you had to do for homework, very much like number 1. I have a vertical asymptote, so I have something in my denominator. I have a point of discontinuity. That's a factor in my numerator denominator. And I know I need some kind of a ratio with my x values. So I know I need the negative 2x, and I use the plus n. Use your point of discontinuity, negative 2, 0. Notice you use your point of discontinuity and any of your zeros, whether they be your x-intercept or your y-intercepts. You just have to have, or they give you a weird point that's on the function. And here's case in point. If you factored it, that's fine. If not, I get it that you didn't factor it out. It's easier to see if you didn't factor it out. If you wanted to make the denominator x squared minus 4, that's fine. Whichever way you do it, it's kind of easier to leave it in factored form, just so that you can go back and check. 3 gave us a y-intercept. Instead of a point of discontinuity, you had a y-intercept. That's your xy. So get everything else set up. Get your ratio 2 to 1 for your horizontal, and then your plus n. Set that equal to your y-intercept at 0, negative 2/3. Get your fraction set up and just cross-multiply it to solve for n. And again, the difference from here to here is just that I factored out the 2. Anybody have questions on these? They're going okay? They're a little difficult at first, but once you kind of see it, I think it makes everything make more sense. That all the things we've been pulling out, they actually make more sense when you have to put them back in. I think. Maybe not, but that's fine. Okay, slant asymptote works a little bit different. Make sure you set your denominator up because that's important. And pull out that 1. That's what your denominator is equal to. When we set that equal to 0. Set up what would have been the result of your slant asymptote and find its remainder. And use the point, one of your zeros is located at 0, negative 1. Use that point. At the very end, put this guy in your y1, put your slant asymptote in your y2. If your slant asymptote isn't guiding your end behavior, you'll see that your equation was wrong. So it's a nice way to check your equations. Yes?
Why did you do that division?
Because your denominator has a vertical asymptote, so that goes down here, right? And that's all we really can tell from here. Now, when we do a division, so say this was our problem. Say it was x squared plus 2x plus 3 over x minus 2. Say we were going to do a slant asymptote. You would say the degree in the numerator is 1 more than degree in the denominator, right? You would pull out all your coefficients, and then you would set this equal to 0 because this is a 1, and you'd put the 2 here. So that's why your 1 is going here. This really is irrelevant here because we're not actually dividing. What we need to do is make sure you have this here too. We're bringing this back here. I set this up so that you could see it came from a slant asymptote, but we actually don't use this part of it at all. But it's where the slant asymptote would have come from. So what we need to find is the remainder, and the remainder has to go over the x minus 1 because that's your denominator. So this part up here, irrelevant, but this is the part we need to get to. When you get to this part, you got to have a point to plug in. So we plugged in your 0, -1. When you find your remainder, bring it back up to here, and then develop your rest of your formula, your equation. I think some of the other ones we did a 0. So in the end, even though we put the 0 at the top, at the end, it actually was a trinomial that we would have factored to see that 0. Because the 0 can't go away, it just maybe takes another form. It gets factored into something.